Hi, very good morning. So we will start to preparation for the quant analyst role, and I will give you the detailed syllabus today. Today was the first day for that course, so I will explain you the entire syllabus. But first, I want to give you the detail about me. So my name is Harshil Dagachi Patil. I have done BSc in mathematics and MBA in finance and marketing, and also completed certification in a business analyst field from the COAPD and the Udemy. And also I am pursuing the certification of quantitative analyst from the Indian Institute of Quantitative Finance. So that's all about me. So first of all, I want to give you the detailed description of the syllabus which I am covering that in this course. So let's start for that details. So the syllabus for the preparing the quantitative analyst role. In that syllabus I cover all the key topics and key syllabus part in that course that will help you to become a quant analyst. So first we will start to learn the core mathematics and the statistics. In this I will teach you the linear algebra, then probability and statistics, then calculus, and then optimization, and then stochastics calculus. First, in linear algebra, I will teach you the vectors, matrices, eigenvalue, eigenvector, how these should be the business quantitative analyst will use, and how the what are the applications of these in the portfolio optimization and risk modeling. All the key terms in use in that linear algebra. All these things I will cover for you, and I will give you in detail knowledge related to the linear algebra. And then we will move to the probability and statistics. In probability and statistics, we will learn the probability distribution such as uh, normal distribution, log normal distribution, and the other distribution which are distribution we use in the quantitative finance. And then we will learn the hypothesis testing, p value, confidence interval part, and then I will give you the Bayesian interface and its applications in the quantitative analyst world. So then we will move the calculus. In calculus, I will, what are the applications of the differentiation and integration in the sensitivity analysis, such as Greeks, Vega, Gamma, Delta, Theta applications, and also the option pricing with the change in the some variables such as the interest rate or the change in rate, volatility, time, how what are their impact on the option pricing. So let's then we will move the optimizations techniques such as linear and non-linear programming, constraint optimization using the Lagrangian multiplier. These things I will guide you in detail. And then we will move to the stochastic calculus. So we know the price of the assets such as are not the deterministic, they are time dependent, and there are many factors that can impacted on the price of the assets. So we need to do in a stochastic calculus. So we will use the technique like Brownian motion, Nito's lemma, stochastic differential equations. That's all thing I will guide you, and then applications in modeling the asset pricing. So after completing the core mathematics and statistics part, then we will move the financial theory. In financial theory, I will teach you the financial market and instrument, and portfolio theory, risk management, and the options pricing. In the first part, that is the financial market and instrument, I will teach you the bond, stock, derivative, options, features, their the key characteristics, terms, and what are their products, features, and how the quant analyst should use these things, and what are the roles of the quant analyst in the stock, bond, and the derivative market, and their mathematical concept. Then we will understand the in detail of the yield curve, term structure, and the interest rate, how they are used for the quantitative analysis field. Then we will move the next topic, that is the portfolio theory. In portfolio theory, I will teach you the modern portfolio theory, capital asset pricing model, and efficient frontier. These things I will give you in detail, and they are the elements and their mathematical concepts, and we will take some examples and solution with the help of Python and Excel. We learn this thing. And then we will move to the risk adjusted performance matrix, Sharpe ratio and Sertano ratio. I will how these matrices we use in the risk management. And then we will move to the risk management, such as the value at risk, var, expected shortfall, and the stress testing, scenario analysis, and more. We will look all these things and their element in detail, how the what are their applications, and when we will use these things by the quantitative analyst in mathematical terms. And then we will move the next topic, that is the options pricing. In option pricing, I will give you details about the Black-Scholes model, binomial tree, Monte Carlo simulation, Heston model, and also what are their applications, when which model we should use, and what are the pros and cons of each model, and what are their applications for that model. Also, we will cover the Holy model, CIR model. These all models we will cover, and then we will look at the Greeks, such as the delta, gamma, vega, rho. All these Greeks will learn in detail, and what are their impact uh, on the financial market. So then we will move the third and the topic that is related to the programming and tool. So in programming language, I will teach you the Python's applications, such as libraries, in that is the Python libraries, NumPy, Pandas, Scikit-learn, TensorFlow, and PyTorch. And also in R for the statistic analysis, and also how to write the SQL queries, and I will give you the basics of the SQLs, and data query and database management we use for the SQL. And then we will move for the data analysis. In data analysis, we will learn the data cleaning technique, pre-processing, and visualization, how we should visualize the data with the help of Python and the Excel. We use the matplotlib to, and the Seaborn libraries for the data cleaning and for the data analysis. And also we will learn the time series analysis and forecasting. And they will move for the quantitative libraries. These are the libraries specially built for the quantitative techniques, such as the Quant Lab, Y Finance, and Stat models. And specialized tools, Bloomberg Terminal, MATLAB. We will learn this thing in a perspective of the quantitative analyst role. And then we will move for the big data tools, option for some rules. These are the options for some rules, hand loop, Spark, and other distribution computing framework. These will things we will learn. And then most important topic, that is the machine learning and AI. The currently these are the AI and machine learning highly used by the quantitative analysts. And in these we will learn the supervised learning, unsupervised learning, deep learning, and the neural network pre-processing. In a supervised learning, I will give you the detailed description about the regression model, decision tree, random forex, XABoost applications in predictive modeling and asset pricing forecasting, how the quant analysts will use this technique for their day to daily activities, how can portfolio theory optimization, how can predict the bond price and the stock price, derivative price. So with the help of supervised learning. And then we will move to the unsupervised learning, the clustering, principal component analysis, PCA, dimensionality reductions, and applications in market segmentation and risk factor analysis, how their applications how their applications of unsupervised learning in the field of quantitative analysis. And then we will move for the deep learning, such as neural network techniques, such as MLP, CNN, RNN, and lead short term memories. These techniques we will learn. And we will also go to the GitHub and prepare the one model or one entire process flow from the GitHub. And then applications in high frequency trading and sentiment analysis, we will learn these things also. And natural language pre-processing, NPL, natural language pre-processing in text analysis for news and sentiment modeling. This model we will also build for the quantitative perspective. And then most important topic, that is the quantitative finance. So in the quantitative finance, I will explain you in detail the fixed income and derivative, stochastic process, Monte Carlo simulation, and the algorithm trading. So in a fixed income and the derivative, we will look at the duration, convexity, and advance bond pricing, how the interest rate we will change, how the time will change, and how the volatility will impact on the interest rate derivative and swaps. We will learn these things in detail. And then in a stochastic process, geometric Brownian motion, Heston model, applications in volatility modeling and option pricing, we will learn these things in detail. Ito's lemma, all these things we will learn. And then we will move to the Monte Carlo simulation. What are the key elements we use in the Monte Carlo simulations, how we will use the Monte Carlo simulation for pricing the complex derivative, how the we will use the Monte Carlo simulation in the risks and the portfolio analysis, what are the applications on the VAR, expected shortfall, or the hull white model of the Monte Carlo simulations. We will learn these things in detail. And then we will move for the algorithm trading, such as the back testing strategy, execution algorithm, market microstructure, and high frequency trading. We These things we will learn in the algorithm trading part. And then we will move, after completing all these things, we will move to the practical applications of the what we will learn from the previous. So the we will take one project from the GitHub, and I will explain you in detail from that project. And we will build the stock price prediction model using the LSTM, develop an option pricing library in Python, and then design the backtesting algorithm strategy. Case study, we will take some case studies of the risk management for the fixed income portfolio, valuation of exotic derivative, barrier option, ASEAN. These valuation we will take. And we will also do the scenario analysis for stress testing. After completing these, we will move for the interview preparation and soft skills. That should you have to become a quantitative analyst in the top oriented organization. So we will focus on the communications complex, explain the complex model and non-technical stakeholder, what are these things. And then we will move the problem solving practice with quantitative puzzles and brain tester and behavioral skills, demonstrate the teamwork and adaptability. And we I will suggest you some books that you should refer to gain more knowledge regarding to the quantitative analysis and market analysis field. Such for the books, we can refer the option features and derivatives for by John Hull, quantitative finance for Demins by Steve Bell, and Python for data analysis by Wes McNee. And also, if you want to learn more about the quantitative analyst roles and their syllabus, so you can join some courses on the Coursera, Edu, and Udemy for financial engineering, machine learning, and Python. And also, you can practice what we learn from that course on Kaggle for a data science project, and LeetCode for algorithm programming solving. And you can go on the Google and check how the quant analyst, more about the quant analyst. And it was the high paying profile quantitative analyst. And the market demanding for the quant analyst role, you can go for the market risk analyst, credit risk analyst. You can also learn the loss given default, probability given default. All these concepts are used by the quantitative analyst. And in quant analyst, there are the huge scopes. You can learn many things from the quantitative analyst. So let's the all of the aspirant from my side, best of luck. You can achieve what you want, and also learn from the everywhere in the world, and gain knowledge and improve the your knowledge size. So best of luck, and thumb for all, and congratulations, you are on the way where you can grow. So thank you.